The understanding of ASHRAE 90 requirements regarding lighting control is accurate. Relay control panels are increasingly common in commercial buildings because they help meet energy efficiency standards. ASHRAE 90 mandates the use of automatic lighting controls to shut off lighting in unoccupied spaces. This applies to interior lighting in buildings larger than 5,000 square feet. Acceptable automatic control devices include a time-of-day operator, an occupant sensor, or a device enabling occupant intervention. Occupant intervention refers to the ability of occupants to manually turn lights on and off. However, the relay control panel must remain the primary controller of the lighting system. This prevents occupants from overriding the automatic control and leaving lights on indefinitely. Relay control panels provide a centralized method for controlling lighting loads, ensuring they are off when not in use. This reduces energy consumption and supports compliance with ASHRAE 90. Many jurisdictions now require relay control panel installation in commercial buildings to comply with ASHRAE 90. It is becoming increasingly common to see these panels in new construction and renovation projects. The function of a relay control panel in an ASHRAE 90 compliant lighting system can be further understood by examining its components and operation. Firstly, the panel itself is an enclosure, typically a metal cabinet, containing the relays, control circuitry, and power supplies necessary to switch lighting circuits. Secondly, the relays are electromechanical or solid-state switches that control the flow of electricity to the lighting fixtures. These relays are the workhorses of the system, physically turning the lights on and off. Thirdly, the control circuitry includes the logic and programming that determines when the relays should be activated or deactivated. This circuitry receives input from various sensors and control devices. Fourthly, time clocks are often integrated into the control circuitry, allowing for scheduled lighting operation based on the time of day. This enables automatic shutoff during unoccupied periods. Fifthly, occupancy sensors detect the presence of people in a space and trigger the lights to turn on or off accordingly. These sensors contribute to energy savings by ensuring lights are only on when needed. Sixthly, manual switches allow occupants to override the automatic controls and turn lights on or off manually. However, the system is designed to prevent lights from being left on indefinitely. Seventhly, a building management system, or BMS, integration allows the lighting control panel to communicate with a central control system, providing remote monitoring and control capabilities. This enables facility managers to oversee lighting performance and make adjustments as needed. Eighthly, power supplies provide the necessary voltage and current to operate the relays, control circuitry, and sensors within the panel. A robust power supply is essential for reliable operation. Ninthly, wiring and connections ensure proper communication and power distribution between the various components of the system. Proper wiring practices are crucial for safety and performance. Tenthly, surge protection devices protect the panel and its components from voltage spikes and surges, preventing damage and ensuring reliable operation. In operation, the relay control panel receives input from various sources, including time clocks, occupancy sensors, manual switches, and the building management system. Based on this input, the control circuitry determines which relays should be activated or deactivated. When a relay is activated, it closes the circuit, allowing electricity to flow to the lighting fixtures and turning them on. Conversely, when a relay is deactivated, it opens the circuit, cutting off the flow of electricity and turning the lights off. The system is designed to prioritize energy efficiency while providing occupants with the ability to control their lighting environment. For example, during scheduled unoccupied periods, the time clock will trigger the relays to turn off all lights. If an occupant enters the space, the occupancy sensor will detect their presence and turn the lights back on. When the occupant leaves, the lights will automatically turn off after a predetermined period. Occupants can also use manual switches to turn lights on or off as needed. However, the system is designed to prevent lights from being left on indefinitely, typically by automatically turning them off after a set period of inactivity. The integration with a building management system allows facility managers to monitor lighting performance and make adjustments as needed. For example, they can adjust the time clock schedule, modify occupancy sensor settings, or override the automatic controls in specific areas. The relay control panel provides a flexible and energy-efficient solution for managing lighting in commercial buildings, ensuring compliance with ASHRAE 90 and other energy efficiency standards. To further clarify the role of occupant intervention, it's important to understand how manual switches and override functions are typically implemented within a relay control panel system. Firstly, momentary contact switches are commonly used as manual switches. These switches only provide a signal to the control system when they are pressed and released. They do not latch in the on or off position. Secondly, the control system interprets the signal from the momentary contact switch to toggle the state of the lights in the controlled area. For example, pressing the switch once will turn the lights on, and pressing it again will turn them off. Thirdly, a timer is often incorporated into the control system to limit the duration of manual overrides. This prevents occupants from leaving the lights on indefinitely after manually turning them on. Fourthly, after the predetermined time has elapsed, the control system will automatically turn the lights off, regardless of the state of the manual switch. Fifthly, the duration of the override timer is typically adjustable to accommodate different occupancy patterns and user preferences. Sixthly, some systems incorporate a two-level switching scheme. This allows occupants to select between different lighting levels, such as a reduced level for general illumination and a full level for specific tasks. Seventhly, the control system can be programmed to respond differently to manual switch inputs depending on the time of day or occupancy status. For example, during scheduled occupied periods, the manual switch may have full control over the lights. Eighthly, during scheduled unoccupied periods, the manual switch may only be able to turn the lights on temporarily, with the override timer set to a shorter duration. Ninthly, visual indicators, such as LED lights, are often used to indicate the status of the lights and the override timer. This helps occupants understand how the system is operating. Tenthly, the system may include a lockout feature that prevents manual overrides from being used during certain periods, such as during energy-saving events or when the building is closed. The goal of these features is to provide occupants with the flexibility to control their lighting environment while ensuring that the system continues to operate in an energy-efficient manner. By limiting the duration of manual overrides and providing visual feedback, the system helps to prevent lights from being left on unnecessarily. The increasing prevalence of relay control panels is not solely due to ASHRAE 90. Several other factors are contributing to this trend. Firstly, more stringent energy codes and standards are being adopted at the state and local levels. These codes often incorporate ASHRAE 90 requirements or even exceed them, further driving the adoption of energy-efficient lighting control systems. Secondly, utility companies are offering incentives and rebates for the installation of energy-efficient lighting control systems. These incentives can significantly reduce the upfront cost of installing relay control panels, making them more attractive to building owners and developers. Thirdly, advances in technology have made relay control panels more reliable, affordable, and easier to install and maintain. Solid-state relays, for example, offer longer lifespans and greater energy efficiency compared to electromechanical relays. Fourthly, the growing awareness of the environmental and economic benefits of energy efficiency is driving demand for energy-efficient lighting control systems. Building owners and tenants are increasingly recognizing the value of reducing energy consumption and lowering operating costs. Fifthly, the increasing adoption of building automation systems is creating a greater demand for integrated lighting control solutions. Relay control panels can be easily integrated into building automation systems, providing centralized monitoring and control of lighting performance. Sixthly, the availability of standardized communication protocols such as DOLI and BACnet is facilitating the integration of lighting control systems with other building systems. This allows for more sophisticated control strategies and greater energy savings. Seventhly, the increasing demand for flexible and adaptable lighting systems is driving the adoption of relay control panels. These panels allow for easy reconfiguration of lighting zones and control strategies to accommodate changes in occupancy patterns and building layouts. Eighthly, the growing use of LED lighting is creating a greater need for sophisticated lighting control systems. LED offer dimming capabilities and other advanced control features that can be easily implemented using relay control panels. Ninthly, the increasing focus on building commissioning is ensuring that lighting control systems are properly installed and configured to maximize energy savings. Commissioning agents verify that the systems are operating as intended and that they meet the building's energy performance goals. Tenthly, the rising cost of energy is making energy efficiency a high priority for building owners and tenants. Relay control panels can help to reduce energy consumption and lower operating costs, making them a valuable investment. In addition to meeting ASHRAE 90 requirements, relay control panels can provide a number of other benefits. Firstly, they can reduce energy consumption and lower operating costs. Secondly, they can improve the comfort and productivity of building occupants by providing better control over the lighting environment. Thirdly, they can extend the lifespan of lighting fixtures by reducing the amount of time they are in operation. Fourthly, they can enhance the safety and security of buildings by providing automatic lighting control in emergency situations. Fifthly, they can simplify the management and maintenance of lighting systems. Sixthly, they can increase the value of buildings by improving their energy efficiency and sustainability. When selecting a relay control panel, it is important to consider the following factors. Firstly, the size and complexity of the building and the lighting system. Secondly, the specific requirements of ASHRAE 90 and other applicable energy codes. Thirdly, the desired level of control and flexibility. Fourthly, the budget for the project. Fifthly, the availability of qualified installers and service providers. In summary, relay control panels are becoming increasingly common in commercial buildings due to the need to meet energy efficiency standards, comply with ASHRAE 90 requirements, and reduce operating costs. These panels provide a centralized method for controlling lighting loads, ensuring they are off when not in use. The components include the enclosure, relays, control circuitry, time clocks, occupancy sensors, manual switches, BMS integration, power supplies, wiring and connections, and surge protection devices. They offer a number of other benefits, including improved comfort and productivity, extended fixture lifespan, and enhanced safety and security. When selecting a relay control panel, it is important to consider the size and complexity of the building, the specific requirements of applicable energy codes, the desired level of control and flexibility, the budget for the project, and the availability of qualified installers and service providers. To expand on the functionality and integration of relay control panels with building management systems, or BMS, consider the following aspects. Firstly, communication protocols are essential for seamless integration. Common protocols include BACnet, Modbus, and LONWorks, enabling the BMS to communicate with the relay control panel and exchange data. Secondly, real-time monitoring allows the BMS to monitor the status of individual lighting circuits, energy consumption, and occupancy sensor activity. This data provides valuable insights into lighting performance and energy usage. Thirdly, remote control enables facility managers to remotely control lighting circuits, adjust schedules, and override automatic controls from the BMS interface. This provides greater flexibility and control over the lighting system. Fourthly, scheduling capabilities allow the BMS to create and manage lighting schedules based on time of day, occupancy patterns, and other factors. This ensures that lights are only on when needed, minimizing energy waste. Fifthly, occupancy sensing integration allows the BMS to receive input from occupancy sensors and adjust lighting levels accordingly. This ensures that lights are automatically turned on or off based on occupancy, maximizing energy savings. Sixthly, demand response capabilities allow the BMS to automatically reduce lighting loads during peak demand periods in response to signals from the utility company. This helps to reduce strain on the power grid and lower energy costs. Seventhly, alarming and notifications alert facility managers to any issues with the lighting system, such as lamp failures, relay malfunctions, or occupancy sensor errors. This allows for prompt troubleshooting and repairs. Eighthly, energy reporting provides detailed reports on lighting energy consumption, highlighting areas for improvement and tracking energy savings over time. This data can be used to optimize lighting performance and demonstrate the effectiveness of energy-saving measures. Ninthly, integration with other building systems such as HVAC and security allows for coordinated control strategies that optimize overall building performance. For example, lighting levels can be adjusted based on the time of day and occupancy patterns to reduce heating and cooling loads. Tenthly, custom programming allows for the creation of custom control strategies tailored to the specific needs of the building and its occupants. This provides maximum flexibility and control over the lighting system. When integrating a relay control panel with a BMS, it is important to ensure that the system is properly configured and commissioned. This includes verifying that the communication protocols are properly configured, that the data points are mapped correctly, and that the control strategies are functioning as intended. It is also important to provide training to facility managers on how to use the BMS to monitor and control the lighting system. By properly integrating a relay control panel with a BMS, building owners and managers can achieve significant energy savings, improve building performance, and enhance the comfort and productivity of building occupants. Furthermore, it's helpful to elaborate on specific scenarios and applications where relay control panels demonstrate their value in meeting ASHRAE 90 requirements. Consider the following cases. Firstly, open-plan office spaces often have varying occupancy patterns throughout the day. Relay control panels, combined with occupancy sensors, can automatically turn off lights in unoccupied areas, even if other parts of the office remain occupied. Secondly, conference rooms are typically only used for meetings, which occur at irregular intervals. A relay control panel can ensure that lights are only on when the room is occupied, preventing energy waste during periods of inactivity. Thirdly, hallways and corridors are often illuminated 24 hours a day, even though they may only be used intermittently. A relay control panel, combined with motion sensors, can dim or turn off lights in these areas when no one is present, saving energy without compromising safety. Fourthly, warehouses and storage facilities often have high ceilings and large open spaces. A relay control panel can divide these areas into zones, allowing lights to be turned off in unoccupied zones while keeping them on in areas where workers are present. Fifthly, retail stores often have complex lighting systems with multiple zones and control requirements. A relay control panel can provide centralized control over these systems, allowing for efficient management of lighting levels and energy consumption. Sixthly, parking garages require lighting for safety and security, but they are often unoccupied for long periods. A relay control panel can dim or turn off lights in unoccupied areas, while maintaining adequate lighting levels in areas where vehicles or pedestrians are present. Seventhly, schools and universities have a variety of spaces with different occupancy patterns, including classrooms, libraries, and gymnasiums. A relay control panel can provide customized lighting control for each space, optimizing energy efficiency and occupant comfort. Eighthly, healthcare facilities require reliable and energy-efficient lighting systems. A relay control panel can provide centralized control over these systems, ensuring that lights are on when needed and off when not needed, while also providing backup power in case of a power outage. Ninthly, industrial facilities often have harsh environments and demanding lighting requirements. A relay control panel can provide robust and reliable control over these systems, ensuring that lights are on when needed and off when not needed, even in challenging conditions. Tenthly, government buildings often have strict energy efficiency requirements. A relay control panel can help these buildings meet those requirements by providing efficient and reliable lighting control. In each of these scenarios, a relay control panel can provide significant energy savings and improve the overall performance of the lighting system, while also ensuring compliance with ASHRAE 90 requirements. The use of relay control panels extends beyond simple on-off switching. Advanced dimming control is also frequently integrated. Firstly, step dimming allows for predefined light levels, like 100%, 75%, 50%, and 25%, offering energy savings while maintaining adequate illumination. Secondly, continuous dimming provides finer control, adjusting light output smoothly from 1% to 100%, often used with daylight harvesting to balance artificial and natural light. Thirdly, daylight harvesting utilizes sensors to measure ambient light and automatically adjust electric lighting, reducing energy consumption near windows and skylights. Fourthly, occupancy-based dimming reduces light levels in unoccupied spaces rather than turning them off completely, providing a sense of security and reducing the shock of sudden darkness. Fifthly, task tuning adjusts light levels to suit specific activities or user preferences, improving visual comfort and productivity, particularly in office or industrial settings. Sixthly, personal control systems allow individuals to adjust lighting in their immediate workspace, enhancing comfort and accommodating diverse needs. Seventhly, time-scheduled dimming gradually reduces light levels during periods of low activity, such as evenings or weekends, saving energy while maintaining a safe environment. Eighthly, load shedding automatically reduces lighting loads during peak demand, preventing overloads and lowering energy costs. Ninthly, color tuning adjusts the color temperature of light to match the time of day or task requirements, improving circadian health and visual comfort. Tenthly, emergency dimming reduces light levels during power outages while maintaining minimum illumination for safety, extending backup power duration. These dimming strategies, when integrated with relay control panels, offer significant energy savings and improved user experience, making them a valuable tool for meeting ASHRAE 90 requirements and optimizing lighting performance. Also, it is important to note that the installation of relay control panels is governed by various codes and standards beyond ASHRAE 90. Firstly, the National Electrical Code, ONEC, Article 725 covers the installation of Class 2 and Class 3 remote control, signaling, and power-limited circuits, which are commonly used in relay control systems. It specifies wiring methods, overcurrent protection, and other safety requirements. Secondly, the NEC Article 404 addresses the installation of switches, including those used in relay control panels. It specifies requirements for switch ratings, wiring methods, and grounding. Thirdly, the NEC Article 408 covers the installation of switchboards and panel boards, including those used as relay control panels. It specifies requirements for panel board construction, overcurrent protection, and grounding. Fourthly, the National Fire Protection Association, or NFPA 101, the Life Safety Code, specifies requirements for emergency lighting and exit signage, which are often integrated with relay control panels. It specifies requirements for backup power, illumination levels, and testing. Fifthly, the International Building Code, or IC, references ASHRAE 90.1 and other energy efficiency standards, which may require the installation of relay control panels. It also specifies requirements for fire alarm systems, which may be integrated with relay control panels. Sixthly, Underwriters Laboratories, or ALL, Standard 508. It covers the construction and safety of industrial control panels, including relay control panels. It specifies requirements for component selection, wiring methods, and testing. Seventhly, the American National Standards Institute, or ANSI, standards may apply to specific components used in relay control panels, such as relays, switches, and power supplies. Eighthly, state and local building codes often incorporate or reference the NEC, NFPA 101, and NIBC. These codes may have additional requirements for the installation of relay control panels. Ninthly, utility company requirements may specify additional requirements for lighting control systems that are connected to the grid. These requirements may include demand response capabilities and energy monitoring. Tenthly, project specifications may specify additional requirements for the installation of relay control panels, such as specific brands of components, wiring methods, or testing procedures. It is essential to consult all applicable codes and standards before installing a relay control panel to ensure compliance and safety. Also, documentation and labeling should be provided with the system.